Alright, so let's talk about programming, given that that is the purpose of this course, this Intro to Computer Programming. So when we talk about programming, what we're really talking about is the act of creating a set of instructions for a computer to follow. Now often, this set of instructions will solve one or more problems for a user, but not always. Sometimes there are programs that you make for fun, there are programs you make for learning, and sometimes we have software that simply does not work. Now, programming is a bit different to computer science in that programming is the act of creating those instructions, whereas computer science is the study and creation of sort of all the theory behind it. Programming takes an algorithm that's already been created and puts it into play. Computer science creates that algorithm and compares it to other algorithms to try to do different things. As a brief overview. And so when we're programming, we're going to write our software in one or sometimes more programming languages. And all programming languages is an organized and codified set of instructions which you can use to create software. The programming language we use in this course is Java, which we'll talk about in a bit. Now, programming languages are categorized by how they interact with the hardware, and more to the point, by how much decision-making this programmer is expected to make with regard to the fine-tuned details of it all. So the first type of programming language is an assembly language. And assembly languages exist in a way that directly interacts with the hardware. That is to say, assembly languages vary from processor to processor. The processor is the thing that does the computing. And what will happen is the assembly language will tell it exactly what that needs to look like. You can see an example of this in your textbook, but when you talk about assembly languages, what we're talking about generally is something that interacts with each tiny little piece of memory and with each component directly. So assembly language, as you can imagine, is a lot harder to write than, say, written English, and usually doesn't look like written English. The next type of language we're going to talk about is a low-level language like C and C++. These are pretty common languages that you might use to generate software and to create software. And while they don't directly interact with the components, they still let you pretty much directly control things like the memory allocation and the ways that different processors split up tasks if you're talking about a multi-threaded application. Low-level languages tend to be, when well written, extremely fast. The downside, though, is that you have to make sure that you finally control every element of everything, which is to say that if you reserve a piece of memory to store some information, you also have to free up that memory later. If not, you end up with things like memory leaks. High-level languages, and that's what we're using in this class, would be a language like Java or Python or Ruby. Typically, high-level languages pass through one or more intermediary steps before interacting with the operating system at all, and are usually designed to be able to be run on as many different types of operating systems as there are operating systems with minimal modifications. Some high-level languages, like Java or Scala, are compiled, much in the way that most low-level programming languages are. Others, like Python and Ruby, go through an interpreter, so you never compile it directly, but it still has a thing that lets it run. Now, the advantage to a high-level language like Java is that it lets you mostly ignore the way that the computer works, and instead you can just focus on the software and the parts of the software that solve your user problems. The disadvantage, of course, is that high-level languages are often slower than their low-level counterparts, but the slower runtime usually doesn't matter. Now, Java, which is the language we'll be using in this course, is a high-level language that was released in the 90s by Sun and is now owned by Oracle, and was designed to be an enterprise business solution geared towards mobile devices. Back in the 90s, Sun Microsystems saw that we were getting more and more mobile devices like phones and like embedded microchips and whatnot. And so they wrote Java in response to that in hopes that it would be able to be sort of a unifying element. Now, Java runs on the Java Virtual Machine, which runs on almost all operating systems, which then lets you write a single piece of software that then runs on almost any computer. Now, this might not seem like much now because most software works that way, or most software has multiple versions, but back in the day, you had to not only write different pieces of software for your different operating systems, but sometimes different pieces of software for different chipsets. The Java Virtual Machine, though, frees you up and lets you use a Mac, a Windows PC, a Linux PC, pretty much interchangeably. And so for this reason, and also because of some of the architectural decisions that were made with Java, Java is pretty commonly used to write business software. and is in fact one of the most commonly used languages in the world. Now your development process is going to be pretty straightforward. You're going to write the program, you're going to compile the program, and you're going to run the program, and then you're going to keep repeating this until you have a fully functional piece of software. When we write Java programs, we typically use a text editor. In this course we'll use Vim, but there are also things like Emacs or Sublime Text or Notepad++, or with more complicated projects you use an integrated development environment like Eclipse, NetBeans, or IntelliJ. You can use Eclipse in this course, but for my purposes I'm going to assume that you'll use Vim, which looks just like Notepad. And this is what this looks like. You'll note that a lot of this code doesn't look too far from regular text. That system.out.print, we can see that that probably prints something to the screen. The that input getter.nextLine, that's going to get the next line of something. And so yeah, this is a thing that we can do. In well-written code, when written correctly, often looks sort of like plain English. That is to say, it's readable. Now, but before we can run the source code, and the source code is stored just as plain text that looks just like this, just a regular text file, we have to compile it, which then turns it from plain text into machine code, which we can't really understand, but which the Java virtual machine understands and runs, and which we keep in a class file. Machine code looks sort of like this. That is to say, it's not very much fun to work with. But this is the only way that your programs can run, and we get to this by compiling. I'll show you more about what that looks like in just a second. Now, we never work directly with the machine code class files. This is what our Java virtual machine runs. We only work with the source code and then create the machine code from that automatically using the compiler. And so, from this, we're going to take a break, and when we come back, I'll show you what the workflow looks like.